Hi, very good morning. And as I mentioned yesterday, that I would like to continue the discussion that we had been doing in chapters 2. Okay, we stopped at section 2.5, 2.4. So I promise you that I'm going to go ahead and then cover 2.5, 6, 7, 8 in another video. So if you can remember that what we had been doing so far, that we were talking about some kind of a function, some packages, okay, and then how to get the data frame, name the data frame, and the vectors, how to give a name our object, which is called our object, how to assign to another name called our object, and what else, and especially when it comes to the data frame, within the data frame, that it consists of the observations or the subjects, row-wise and column-wise. We're going to carry all the variables. We talk about the variables, different kind of variables, classification of variables, and inside that data frame, especially that if you really want to do some, we saw that there are mainly two types of that variables: categorical variable, which were that abbreviated as cat, and then numerical variable, which are abbreviated as num. And then we have the sub-classification. We did that one very first day, and then even yesterday I barely mentioned about it. But anyhow, that there's our main two variables will be taken into account. Okay, so those were the characteristics of the variables, then how many observations going to be in that particular data frame, and then if you really want to have like a categorical data, or that label data, or that some kind of a character data, we can convert them to like sometimes even the numbers doesn't mean they were numerical. Sometimes number gonna represent even the categorical data, like in that yesterday we saw that in the gender, that rather than putting male or female, they put the 0 and 1 or 1 and 2, like that. Okay, so that the major part on those, that when they were considered as a categorical, we cannot sum them up. How we going to consider them as a categorical? By giving that, by imposing that, or using that factor function. Can you remember using the factor that we just converted that into like a categorical? Or if you really plan to that keep the numbers, whatever that mean, assigned for the categorical data to be considered as like a numeric, then you have to put the function as dot numeric. You can remember how they did that one. If you convert that one to like a numeric value, then we can easily sum them up and then talk about that aggregate or the averages, median, mode, and all kinds of stuff. Mainly the average. Okay, we can remember we were citing one example of that ratings, average ratings. Average being given, there's a ratings being given on like a 3-point scale. 0, 1, 2, or 1, 2, 3. Let's say 1, 2, 3 on like a 3-point scale. If those numbers being assigned for that each and every day student in that fingers data frame or data set, you can remember, if you're really interested in the average rating, you cannot add them up if those numbers represent a categorical data. If they were categorical data, you cannot add. Yes, they don't make any sense. You have to convert them into those numbers, whatever the values, into numeric by giving, by invoking the function as dot numeric. Okay, you can remember that how we will do that one. So then later on, I was talking about that when you have like a large population, that means that it's like a set of all the individuals, components, subjects, cases, whose characteristics being studied, called the population. From that one, since we cannot access the total population of pretty much everybody, then we were citing an example about that, how to find that average height of all national university students. Then we were talking about that the total population on campus, which is like a total number of students who have enrolled or that admitted to the programs on campus. All programs on campus would be like around 20,000 students. If that 20,000 students, in order to find the average height of all UT students, we cannot go up to all 20,000 students and ask their heights. Or sometimes they're not going to provide, they are the correct measurement. Sometimes they give some kind of a fake numbers. It depends on that, the way that how these experiments are given, okay, they're done. So because of that reason, we cannot access the total population. It's very tedious, time consuming, and it costs a lot. You know, statistics and data analytics are utilized as like a cost cutting technique. Okay, cost cutting technique. That's the key part. That's why we are utilizing statistics and data analytics to cut the cost for big corporations and companies, and then even the government or that private sector. So when it so because of that reason, we're gonna pick a sample. We mentioned about that, how we're gonna pick a sample. We pick a sample. We were talking about the different ways of picking a sample. There are so many the sampling techniques called the simple random sample, random sampling technique, stratified sampling technique, quota sampling technique, systematic sampling technique, sequence sampling technique, census, okay. And anyhow, that any of these techniques, that at the end of the day, you should have like a very representative sample. In that way, everybody should have a equal chance to be elected for this sample. Okay, that's the key part. At the end of the day, we have to make sure we're going to pick the representative. And then I mentioned at a certain point that the stratified sampling technique would be the best sampling technique. There's no something called the best in statistics. Maybe better than the other ones, okay, like that. We can, it depends on the scenario. But then I divided the whole universities, especially that undergraduate student, into that I'm talking based on the undergraduate student, that into 4 groups, and then from each group that we pick like a random sample of size 25, and later on I say that that size 25 would not be reasonable to be picked from each and every group, because each and every group not going to represent the same number of students. They have like a different number of students. If that's the case, you can move on to the quota sampling technique, in which that you're going to pick the number of students proportionally from that proportionally based on how many students going to be in that each and every group, okay, like that. Then I didn't want to go to the detail in that. I mentioned that one. Then again in 2.5, we love to go back to that sampling. That's the same thing that we're going to talk about again in this textbook, based on the textbook. Let's go ahead and see same thing that they were talking about. I would like to go through that one, okay. So I'm going to go ahead and share this screen. See? So again, that sampling from a population, they're going to talk about what do you mean by the sampling techniques. Okay, sample means what's the population. We mentioned about that one yesterday. See, can you remember I drew everything and then I mentioned about that's the same thing that they were talking about. Then random sampling. For sample to be random, every object in the population must have an equal probability of being selected for the study. See, so this is kind of like a population. Population means like a collection of all the individual subjects or components whose characteristics being studied. Everybody. It depends on that what you're going to define as the population. I mentioned that what you're going to define as the population is the key part. Like in when you're interested in average height of all UTC student would be your population, not the any other student from any other university. We're not going to take into account the other university because we are not interested in knowing the average height of all Americans. In that the case, that later on, that if that's the case, that's a different thing. Why we were not going to go only to the colleges, then that kind of a experiment can be carried out it's a tedious task. But anyhow, that when we restrict our discussion based on that scenario, based on the way that how we're going to look at things, that you're going to define the population. Population would be that the set of all individuals, subjects, cases, or components or members whose characteristics being studied. Okay, so in that National University example, we were interested in our study would be for the height. Okay, so the same way that then pick a sample if a random sample as a record, every object in the population must have an equal probability of being selected for the study. In practice, this is hard standard to reach, but if you can have a truly random sample, we can see least try to feel confident that our sample is representative of the population we are trying. But I'm telling you that it is not the proper way of picking a sample. Random sampling technique is not the proper way of picking a sample. As I mentioned yesterday, there are so many sampling techniques. I don't want to go through them in detail because that's not our purpose of this class. But anyhow, I can barely mention again, come back to that one and a little bit go through that one for you to get some kind of a rough idea what's going on with the random sampling and the rest of the sampling techniques. Okay. 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 And as I mentioned yesterday that we have a sampling techniques, See, first one you can say random sampling. There's another one called the simple random sample. Simple random sampling. Sometimes we call this one SRS, NSRS, simple random sample. Stratified sampling, quota sampling, 5 cluster sampling, systematic sampling, sequence sampling, census, sequence, systematic, like that. Okay, those are mainly the sampling technique. In that one, if I gonna get this one to this one, what I'm gonna do, I get the population. This is a population. See, population. I'm gonna divide this into 4 parts, as I mentioned yesterday. See, these are like let's say that freshman. Can you remember in that National University example? This one, sophomores. Here we have a juniors, seniors, like that. See. So that if you want to that a sample of 100, you can go and pick, see, randomly pick, you see, random sample. That's the same thing they were talking about. Randomly pick from that one, see, randomly now you pick, you see, this one in RS. I'm going to call this one RS, random sample, see, random sample of 25. From this one, random sample of 25. This from this one, random sample of 25. Random sample of 25. Random sample means that everybody has an equal chance to be selected. So you're not going to go and then favor anybody, support anybody. Okay, you don't be biasing. We don't be biased. We're going to randomly pick a random sample of 25 from that one. But as I mentioned today, it's not going to be fair. If that's the case, that you have to make sure that you're going to pick proportionally. So this is the stratified sample. See, stratify means layers, subgroup, stratified sampling techniques. In that way, you're going to divide that one, that's whole population into certain number of groups based on a certain characteristics. Here we were using that number of credit hours they have completed. Okay, based on that one, then you will subgroup, you group them into subparts, and then from them, then you're gonna pick the random sample of same number, 25, 25, 25, 25. Right there. So, but in the correct way, if you are doing this one, then if you're gonna do this one, let's say that this is a freshman, this is a sophomore, this is a junior, senior, like that. So if that's the case, that you're going to pick this one proportionally. Pick certain number proportionally. See? So do with all these groups, and then make like a sample of 100. That's called the quota, based on the quota. See? That's a quota sample. Pick certain number of student, okay? Certain number of student. Pick certain number of students proportionally, like that. That's a quota sample, okay? That's the same thing that they were talking about. Then they say that independent sample. Anyhow, look at that, what they were doing over here. See, let's make a like a some kind of a fake this. For example, we created a data frame called fake pop. That means we have a population of fake population, okay? We have a fake population, okay? Fake population. That one has the numbers. What are the numbers? We have a hundreds, 0 hundreds, ones hundreds, twos, threes, and so on, and all the way up to 9. We have a see. In this one has a 0, 0, 0. See, 0, 0, 0. See, like that, and then since these are numbers, see, these are zeros, how many? 100 of them. Then you have 1. How many? 100 of them. Then dot, 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 then we have 800 of them. Continuation. And then we have a 900 of them. That means we have a 100 zeros, 100 ones, 100 like that, all together 1000 rows of cases. Then these numbers, if you put from this vector to like a data frame, see, you can data frame, see, you can say that this one, whatever the numbers, you can convert this into data frame, okay? See, we can give a name to this one, fake pop, okay? So this one, if you want, you can say fake population of this data frame. Maybe data frame. This one I'm gonna say data pop 1. That fake pop 1 being converted into a data frame. See, you can convert into a data frame. Okay. Then once you convert into data frames, you know how they're gonna look like. Then you're gonna have, see, you're gonna have this row wise. See, these are your entries. See, entries. See, you have a 0, 0, 0. See, you have 100 of these. Then you're gonna have 1, 1, Then you have 100 of these rows. See? Then eventually blah 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 8, 8, Then 100 of these. Then you're gonna have a 9, 9, 9. See, 100 of these. See. So altogether you have a what? 1000 rows, and this is the variable. See, that's a variable. That's the number. Variable is the number. Okay, that would represent the pretty much the whole population. See, for this one, if you draw something called the histogram, see, if you draw the histogram, that means having the frequency. If you go ahead and look at this frequency, see, this is nothing but the frequency of 0, frequency or count of 0 is 100. See, like this. And for the one, I can say frequency or count of 1 is 100. See, like that. And so does this one also. See, frequency or count of 8 would be 100. And here, frequency or count of 9 would be 100 as well. See, then if you know that if you run that tally for this data frame, see, tally for that this variable. I'm gonna call this one. For your convenience, I'm gonna say data. Okay, data, and the data has been. See, I'm gonna call this one data. Okay, data would be my variable. See, so that if you get tally of things, see, data in what? Data in fake population, go to that one, and if you go to data, that would give you the same xn frequency. Can you remember? It's gonna show you that frequency, zeros and everything. See, 0, 0. How many zeros? They're gonna say 100, 1, 100, 2, 100, 8, 100, 900, like that. So this is the frequency. This is the data. See, like that. Okay, we know that one. How to get that one? So, but if you put this one into a graph called the histogram, you're gonna have the data. See, your number. See, you're gonna have this one here. See, you have this one here, frequency or count. This time you put the number. That's called the histogram. For the population histogram, you have a 0 here, 1 here, 2 here, dot dot dot, 8 here, 9 here. They all would have same number. See, 100, 100, 100, 100, 100. See, as I mentioned yesterday, if you want, you can combine this one by line, then you have a uniform. Uniform, we're gonna say uniform distribution. Uniform distribution. I'm gonna write this one with the abbreviation distribution. See, distribution. And they're gonna represent by what? The bars. See, each one is represented by bar. See, the way that it's gonna give you, you're gonna see something like that on that graph. See, that's the histogram they were talking about. See, this is the population histogram. That means the count versus the number, count versus the variable. See, this is the variable, number is the variable. See, this is the variable. See, the graph of count or frequency versus variable is called histogram. Since this histogram has been drawn for the population, we're going to call this one population histogram. Make sure you put the frequency on y-axis, see? Number on x-axis, see? Like that. Okay. So how do you get this one? You see, that's how they were showing over here how to get this one. Okay, sorry. Then they draw like that. It's going to be like that. Okay? So then there are 100 each digit. Fake population look like this one, uniform. This distribution uniform. If you go ahead and look at this distribution, it should be uniform. Okay? You have a uniform distribution. There are dot dot here. Okay, there are numbers in between. Okay, see, so uniform. See that one. Now what are you gonna do? You're gonna pick a sample from that guy. See, they give the name number. See, variable call the number. They call the variable number. Sorry, that I think not data. I'm gonna go back a little bit clean up. See, call the number. Okay, sorry, this one. Not even data. They say number. I'm sorry. So I just put something on my own. This one they call a number. Variable name is number. number. Now you're going to make a data frame for number. Your variable name is number. Number would be your name variable. Okay. And the variable is number. On the other page, I think I put the variable equals to number. And under this one, variable is number. See, it's good. See, so what are you going to see? Fake pops go to that number. See, that's how you're going to go to the, first you go to the name of the data set and then go to the variable. See, here's a graph called the histogram that helps you see that that's the population histogram. Now what are you going to see? Now you're going to pick a random sample from this population of size 10. See, you go to the fake population and pick a sample of size 10. Size 10. See, random sample of size 10. And then draw a histogram for that guy. Who? Random sample. This is your new name of the, this is a new data set. This data set consists of 10, not 1000. See, this code will take a random sample of 10 from the fake population. See, as I mentioned over here. See? Now you have a population. You see, you have a population. See, this is your population. This is your population. This population consists of numbers. How many numbers? You have a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 numbers. From each one, you have altogether 1000 numbers. I'm going to put capital N to say population size. Means like a number of individuals in the population. Okay. Number of numbers in the population. That's the population size. And we drew the histogram for that guy. You saw that what happened. See, you saw that what happened. See, this is 1, sorry, this is 0, this is 1, this is 2, dot, dot, dot. This is 8, this is 9, 8 and 9. You saw that this everything's gonna fall. You see, it's a frequency. This is hundreds. You saw that histogram. See, that histogram with that bars gonna represent that frequency for each and every number. You saw that. From this one, now you're gonna pick a sample. Now you pick a sample. Pick a sample of size 10. Size 10. See, that's what we are going to trying to do. This is the sample. That's a sample. See, when you pick a size of nothing, it has a name. I'm going to give a name. It's been assigned to random sample. See, new data frame called. See, data frame, new data frame called the random sample. See, this will make a histogram of your sample. How do you do the random sample? You call the random sample. See, look at how you do. You recall the random sample. You go to GF. See, these are everything, as I mentioned, that all of that these packages been already installed on this DataCamp sandbox on this UCLA textbook. Okay, so you don't have to that if you don't do the same thing on your R, you have to make sure you're gonna that install that proper all the this packages. Okay, you can remember what are the packages. Okay, if I can recall that one more time, these are the packages that I'm talking about. I'm talking about okay, I'm talking about see, I'm talking about see these packages, see dplyr, mosaic, ggformula. So this is the one they are using right now, ggformula. That's why we have a GF. Okay, I'm gonna compare this one for you to see. See, G stand for, sorry, that package. Oh, see, this package this package consists of the function or the command in order to draw the histogram, which is GF histogram. G and F stand for, G stand for GG, that the first letter from the GG, F stand for the formula. So GG formula package will provide GF histogram, GF refine, GF label. See, G stand for GG, F for formula. So in order to get this function, you really need to install the GG formula over there. Okay, that's the key. See, that's how they can see. First, you can recall the sample. This is one way of doing this one. We're going to do this one in large scale later on, how to draw the histogram. But later on, you use something like this. This is called that link operator or chain operator. See, this is a link operator. See, percentage sign greater than percentage sign. That means once you recall the data, and this function will take the data. You don't have to give the data again. It's been given. See, and you go to this function, and then you recall your variable name is number, and you can remember why we put the tilde. We're gonna, after the tilde, anything gonna go to the x-axis. I'm supposed to have the number on x-axis. Can you remember the way that we have drawn? You're supposed to have x on, sorry, number on x-axis, which is the variable. Okay, that's why we're gonna put the tilde, number. Then again combine to this one, and you're gonna say GF refine. See, this means refine. See, you wanna refine that one. See, the scale. See, x continuous breaks gonna be 0 to 9. Okay, I'm gonna run this one, and then see what you get. See, okay. See, you have to make sure that you have the 0 to 9. Okay, it has been scale 0 to 9. See, continuously refine. See, but if you go ahead and look at this one, see, the one that we have and this one not going to be the same, because these are randomly picked, because look at the 4 number here, 0 number. See, there are 2 zeros being selected. There are 3 twos, 5 1. See, 1 5. See, 1 7. See, 2 8, like that. Altogether 10 numbers. See, they've been drawn or represented on this one. On this graph, the one that I have a 1 4, 2 5s, 4 6, 2 7s, and 1 9. See, altogether how much? 1 plus 2 plus this one. Altogether how much? 7. 7 plus 2, 9 plus 1, 10. See, they were represented on this graph. See, they've been breaks this one. See, if you don't use this one, look at what's going to happen. Okay, I'm going to take this out. You see, it's not scale. They're going to take their default scale. See, we want to see the real scale, the scale, not in decimal. See, 2.55, we don't need one of these, so this one. But still, the same thing going to happen. This is for zeros. I have picked like a 2 zeros, then this look like a 1, this look like a 2. See, and 2.5. See, 3, 3.5. That keep going. See, this is 0, 1, 0, 1. This looks like a 2. Sorry, this is 2. 2.5, 3. No, see, the scale has some issues. See, so that's why we're gonna scale it. See, we're gonna scale this one. See, scale of on the x. See, I'm gonna refine the scale on x and making that x-axis by making this one continuous by giving the breaks from 0 to 9. Okay, sorry, I have to get this one here. Now you're gonna see, they clearly see that one. But if you take this out, you don't clearly see. See, to make this one clearly see that you refine the scale. You're going to refine the scale by giving this command. Okay, then you're going to have this one. Look at on the sample, you have a graph like this. This is called the sample. This is called the sample histogram. See, look at the sample histogram, not uniform. Sometimes sample histogram you have a 0 here, something here, 1 here, then 8 would be here. Sometimes there's no 9 at all, or maybe 9. See, one of them. I'm drawing this one. We didn't see this. See. Look at the sample histogram. See, like that. See, not exactly like the population. This one sample histogram. This is a population histogram. Population histogram is a sample histogram. Sample histogram. See, they're not the same. See, they're not the same. See. You can run the R code about a few times and see if different random samples. You'll observe that these samples differ from each other and differ from the population they come from. See, these sample population, if you run this one again, it's not going to be the same as that we had earlier. See, you're not going to have the same thing. That means you're not going to see. That means if I pick a different sample from here, okay, another sample, but the same size, okay, same size. Pick a sample of size 10. I'm not going to change it, but different. Now your the histogram not going to be same like this one. Sometime maybe see. That's it. See, like that. See, like that. This may be just 4, 5, and 6 only. See, who knows that based on the way that how we pick. Okay, randomly pick only 4, 5, and 6 only. See, another one. See? If you keep doing this one, sample to sample gonna different, plus they say they differ from each other and differ from the population as well. They differ from the population for sure. Population is uniform. And the sample gonna change from sample to sample as well. Look at it. Here sample and this sample, see, they're gonna be different too. See? See? That's why they say there's a bias in the country. Notice that even a random sample won't look just like the population it comes from. It doesn't look like that population it's coming from. This fundamental alpha sampling variation is a tough problem. We are going to meet up with sampling variation, not into statistics. See? Sampling variation is called it vary from the population. We're supposed to be considered like a population. See? See where it comes from. See, it is not even look like that. See, these siblings or these offspring are not even look like the parents. But the parental distribution, parental histogram. See, they're different. It's a, see, there's a huge variation. This is called the sampling variation. Sampling variation means that just the sample is differ from the population as well as samples are differ. Sample vary. The shape of the sample going to be differ from each other as well. The bias in the context of sample means that some objects in the population are more likely than others to be included in the sample, even though there aren't actually more of the objects in the population. See, this violates the assumption of an independent random sample because the sampling variation, no sample will perfectly represent the population. But if we select the independent random sample, we can at least know that our sample is unbiased, no more likely to be off in one direction than in another. See? So even though our random sample did not look like just like the population, it was unbiased in that it wasn't more likely to be off in a particular way. Only sampling even numbers or large numbers. So if you keep doing this one, see, unbiased, this one, see, so even though our random sample did not look like just like the population, it was unbiased in that it wasn't more likely to be off in a particular way. If it is not completely differ from the population when we're going to select from the population, that kind of a thing we're going to call the unbiased. When we're going to have the unbiased, when the sampling even numbers and large numbers, The larger the number of numbers that you're going to select, or that if you're going to select that large number of numbers, see, large number of numbers, they will systematically, this shape will systematically getting close to that population shape. Okay, that's why they say. Then we're going to say that these numbers, or it was unbiased. Okay, otherwise it is biased. See? The bias in the context of sampling means that some objects in the population are more likely than others to be included. Some objects are more likely than the others. Some objects more likely than others. See? Some objects more likely than others. Some these are not even being considered. That's a biasness. Unbiased means like that pretty much everybody has a equal chance of to be included in this one. Okay, not like that one object or one number has a more likely than others to be included in the sample. Okay, so that's why in order to that with the unbiased sample, you have to use the large numbers. That means large sample with a size of 100, 200, or maybe 500, like that. Okay. See the structure of the data. See, we know the structure of the data. We talk about the data. See, data can come to us in many forms. If you collect data yourself, you may start out with the numbers written on, see, scraps of paper, or you may get a computer file filled with numbers and words of various sorts, each representing the values and blah blah. Anyhow, statistician, see, Hadley Wickram came up with the concept of what they call the tidy data. Tidy data is a way of organizing data into rectangular table with rows and columns according to the following principle. See, they say each column is a variable according to this statistician Hadley Wickram. Hadley Wickram came up with the concept that they call the tidy data. See, clean data. How they each row, each column is a variable. Each column is a variable. That's clear. Each row is an observation, or we have been called a case or an object to which the measure is attached. Yeah. Each row is an observation. Each type of observation or case, see, each type of case is kept in a different table. More or this, see, more on this below. See, each type of, say, rectangular table of this sort are represented in R using the data frame. The columns are variable. This is where the results of measures are kept. The rows are the cases sample. Data frame provide a way to save information such as columns, headings, see, variable name in the same table as the actual data value. Principle 3 above simply state that the types of observation that from the rows cannot be mixed within a single table. So, for example, you wouldn't have rows of college students intermix with the rows of cars or countries or couples. So that's what they say, that if you have each type of observation or cases is kept in a different table. If you're talking about the student kept together, student will not be intermixed with the countries or the couples. If you have a mix of observation types, let's say that student, families, and countries, they each go in a different table. Let's say that in a certain data set, you have a student, families, and countries, but they don't go to the same data frame. They go to different data frames. See, in the fingers data frame, what do the column represent? Give some examples. Column represent the variables. Rows represent the observation or the cases or the subjects or objects. So, and on the other hand, each type of observation you're gonna kept in a different table. Each type, like that. Okay. So, what are the observations? See, what are the observations in environmental? See, Happy Planet Index measures sustainable well-being of all these. See? In 2007, the Harvard Psychology recruited 75 female housekeepers working in different hotels to participate in a study. She informed 41 of them, randomly chosen, that the work they do satisfies the Surgeon General's recommendation for an active lifestyle which is true. Given them an example for why their work is good exercise. The other 34 housekeepers were told nothing. Various characteristics, weight, body mass index, and so many variables you saw that were recorded for each participant at the start of the experiment, and again 4 weeks later. She recorded her data in the Mindset Matters data frame, the first few lines of which are below. See? Which are below. See? That's the Mindset Matters data frame. See? These are the variables. See? Okay, they say the condition. Condition means whether they've been informed or not. See? Whether they've not been informed, we're going to say 0. Whether they've been informed, we can, those are character variables, so categorical variables, or cat variable. Those cat variable, the variable that items can be represented by numbers, but those numbers doesn't have any numerical value. This is just a label. 0 represent that the housekeepers not being informed, or the people who are going to be in the control group. Control group. Those are called the control group. The people who are in those are not being informed. That's why they say there's some people not being informed, some people being informed. 41 people. See, there are 2 groups here. One group and this group. See, so this is, we can sometimes call the control group. The other one is treatment group. Treatment group. See, in the control group, whether they have been informed or not. See, no. This one, yes. Then how many yes and how many no? See, there are 75 out of 75, 41 people. 41 people being informed. 41. This one. 34 people not being informed. So, like that. See? OUP. See, this is how they get condition, age, weight before, say, in the very beginning of the survey, at the end of the survey, BMI, in the very beginning of body mass index, at the very beginning of the survey, BMI2, at the very end of that survey, the fat before and after, WHR. WHR stands for what? Let me see. Some ratio, I think. Weight height ratio. Sorry. WHR. I'm sorry, waist to hip. I'm sorry, that waist to hip. WHR means waist to hip ratio. Okay. So that one, then systolic pressure, see, diastolic and systolic pressure before and after those things. Okay. So that's how the data frame shows like this. Okay. The Happy Planet Index measures the sustainable well-being for all. It tells us how well nations are doing at achieving long, happy, sustainable lives. What are that observation in the rows in this another data frame? See, Happy Planet Index. This one for, see, my Mindset Matters. See, that's one. This is Mindset Matters. This is Happy Planet. See, this one they were talking about the countries. Country is gonna be your objects or the subjects. Region. Country, region. Happiness, that index. Life expectancy. Footprint. HLY. HPI. HPI pink. HPI footprint, life expectancy. Okay. So one challenge for student to keep track of the difference between an observation, housekeeper or countries, a variable, weight, sex, happiness represented in columns, and the values variable can take. See, those are the numbers here. Those are the values that can take. These are the variables. These are the you can say the observation subjects or that items or members of the data set. row-wise. See, then the same way that if you really need to get the data into data camp, see, you can easily get that one. See, in this course, that's it. One challenge for student. Listen, in this course, we will be providing most of the data you analyze in the tidy format. Okay, you've already been using this format for a bit as we explore data, but now we are making it explicit. It is important to think that data as rows and columns, with rows as observation and column as variable. In the future, you may have to transform non-tidy data set into a tidy one. You know that. So in this course, we have preloaded most of the data set we use into DataCamp. They were preloaded. But you may want to import your own data into DataCamp. In this section, we will teach you one simple way to do that one. That means like wherever you are working over here, if you really want to get a data set, somewhere there's a certain data set, okay, on from the internet or somewhere. See, if you want a data how could we gonna get in that data into DataCamp? In this course, we have preloaded that like each one. Wait. Consider installing RStudio Jupyter Notebook. You have RStudio Jupyter Notebook. Although you can import your own data into DataCamp, you might instead consider installing RStudio Jupyter Notebook on your own computer. Instruction for how to install both can be found in the resources folder. You already did that one. You have RStudio in this one. This is how to get the data into DataCamp. Then we'll say that later on that how to get the data into RStudio, then how to get the data into Jupyter Notebook, like that, okay? Let's say this is the easiest way to get data into DataCamp is through Google Sheets. Here's a step-by-step guide with an example you can try yourself. They're gonna get the data into here through the Google Sheet. The Google Sheet is something like this. You go to the Google, see, you go to Google, over here, if you go down, and see, Google Sheets. See, the blank one, if you get, that's exactly like the spreadsheet. That's a spreadsheet. They have incorporated this one with the Google Sheet. This is where they are trying to get the data and then store, okay, save over there. So the easiest way to get your data into DataCamp through Google Sheet, okay? Here's a step-by-step guide, okay? Get your data into tidy format, rows and columns. Copy, paste or your data into a Google Sheet. See? They are trying to get the data from Google Sheet. That's the plan, okay? That's what they are trying to do, okay? Whatever the data, can you remember we had a data? Okay, I'm gonna go ahead and get the data in that, let's say that our sample one, sorry, homework one, assignment one, homework one, we have a consumer data. This data, see, I'm gonna go ahead and see. Copy this data. This one, see, copy, and from the spreadsheet, let's just, oh no. Copy paste or enter your data into Google Sheets. See, copy and paste. They don't get it. They don't come yet. Let me see. Copy. Paste. Control. Okay, sorry. See, we got that data into this Google Sheet. See, ID, household, kids, vehicle. See, and Google Sheet. This is in Google spreadsheet. Data in the spreadsheet we got into the Google Sheet. Okay. Then what are you gonna see? As an example, we created Google Sheet with the data from a study D-Lodge. Blah, 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 blah. Okay. Click here to this link to make your own copy of the Google Sheet. If you're not logged into your Google account, we will ask you to send. You can do that one too. But anyhow, if you want to publish to the web, then once in the Google Sheet, go on to the file menu and select the publish to the web. See? Go to the file. See? Publish to the web. See? Then you're going to go ahead and pick, see, link, embed, see? You're going to pick the CSV, comma separated, and publish. See? Now what are you going to do? See, it is now in that online. See, now what are you going to do? You're going to copy that one, this link, the copy, that link. They created a link where those will be, okay? And then copy and then see. See, I'm going to copy, and you're going to open your data, that data camp, okay? Then I'm going to go here. Sorry. See. Okay. See, data camp. I'm not talking about this one. I'm going to different thing. Okay. Later on, I come to this one too. Okay. Then I'm going to put this one here. HTTPS. And then I'm going to call this one data frame name. Okay, I'm going to give like I'm going to say X data for X. So I'm going to call data being assigned to, okay, read.csv, okay, read CSV within inverted commas, okay, close it, see. And header true. I'm going to put the header to header TO true, okay. And then data. From the data I get, let's first run and see. I'm gonna take out this one too for time being. Okay. Then I'm gonna go to head and first 6 data entries. See this here. I was talking about that data set, but if you have a data set, this is how you're gonna just get into that one to that Google spreadsheet. From the Google spreadsheet, you're gonna create that, publish to the web. From the web that you're gonna read. Okay. From the web, you're gonna read to the data camp. Now you have a data set. See, data, you have data in your hand. Now you can do whatever you want. See, if you want to draw the histogram for anything like the way that you were doing earlier, I'm gonna paste this one for time being, and let's say this one. Okay, the way that we had earlier, that you go to data. Data means data. Data, you have to put this into data frame. This is the name of the data frame. Okay, so I'm gonna go to the data frame. Okay, sorry, data frame, and then this one, this one. Then I come over here and the GF underscore histogram. I'm gonna draw the histogram. Let's say that for, let's say, kids, but you have to make sure you put the tilde, then kids, then what else? Then kids. See, one out. this one. And 9. Can remember that here the side we had. See now, see. Oh. Oh, it's already gone. So it's okay. So what I'm gonna do, I go ahead and get this one. It's already published. This one. Paste. Then I'm gonna get my URL. Go to Google. That one, see. Spreadsheet. Copy. Okay. And I'm gonna put this one within that double inverted commas. Call that one. That data frame I call the data. The name of the data frame. Then this one. This one. And then I can do like this way. GF program. I can do this way. Then I go to the tilde. Let's say that data we can remember that we can draw the histogram for hours per week if you want. Hours per week. To make sure I'm gonna spell the same way. Week. I'm gonna say for this data set coming from this data. That's a histogram. GF hours. Oh, P. I'm sorry, the P. P capital P. Hours per week. See, you can get the histogram. See, that's the histogram for that particular data. If you want that, instead of doing this way, or can you remember the way that they have done? In the beginning they call the data first, and then you get this link operator, and then put the GF. See, GF underscore histogram. See, then call the variable which is hours per week. Okay, hours per week per week per week. See, and then see there are two of them. It's the same thing. See, either this way. See, either this way or this way. Doesn't matter. See, you're gonna go to the GF histogram and then put the variable tilde variable comma data to equal the name of the data frame. Or you just simply go to the data first and then with the link operator. See, the pipe operator. This is called the pipe operator, link operator. With that one, you don't have to recall that data again. It's already been recalled. There's a big advantage of this one. Once you recall here that you can include as many that function as you want or command, but you still don't have to recall this data because it's already recalled. Okay? Like that. See, you can see that if you go ahead and see. Excuse me, if you use the string for this one. Okay. str for string for that data. So go to our console, will show you that the strings. all the information. But they were doing that another data, another see example called the data. This one I'm gonna place that one there. See, deload this one. See, load the deload. See, data frame to save. See, so continue now example. See, they have already see get this one, but you have to replace the between quotes and blah blah. Continue now example. Let's call the data frame this one. Complete the code in the data camp window below to import data into a data frame. See, it's already been done. See, we should replace URL between the codes. See, you're gonna see. So I use that our data set. Okay. So they have their data set called. See, continue now example. Let's call the data frame Deloach 1997. Complete the data camp in the data window below to import the data into data frame. So where this data coming from? See here. As an example, we have created a Google Sheet with the data. Study this one. Click here if you want to download some. That's the information. Okay. Not this one. Not this one. This one. Okay. See here, blah blah blah. Click here to get the link. If you want the link, see, make a copy. See. See. That's the link. See. See. Gender condition retrievals. Okay. If you want, you can recall that one too. That data set. Okay, let's go back to where we was here. Here, see, I'm gonna recall that one by calling read.csv. It's already been published. Okay, so control V, and I'm gonna say header equals true. And then you can, I'm gonna get rid of this one now. But this one too, don't need that one. And if you run the code that be below, yeah, watch this one, see what you will see. That would give you pretty much everything. Not this one, starting from data frame, okay? Here. See. Data frame, observation, one variable, sorry, here, this one. Data frame, 4 variables. What is this one? 5 levels. This one. Is that the right data frame? See, this one has a 33 and 1, 2, 3, 4. 4 variables. Why we don't see that one? I'm gonna get that one. 4 variables. Say 4 variables. Say 32 observation and 4 variables. Okay, when we do that one. Oh, I think it didn't copy very well. Okay, I'm gonna copy again. It didn't get copied. Okay. Copy and go over here. Paste. Oh, that's another page. Load the data frame, set an object called to Deloach 1997. So they say that, okay, see, this is the place they say, click on this link to make your own copy of the Google Sheet. If you are not logged into your thing, this link, okay? Deloach data CV, make a copy. This is the sheet that they are. Let me see something. I want to see something. You see, that's the same thing. See, for this guy, see, look at the docs. Google, we copied that one from here. Same thing. See, output. Oh, it's not that spreadsheet. Okay, we made a mistake. Okay, I'm sorry. This one, we have to publish this one first. Go and then publish that one. It's not yet published to the web. Okay, so go to this one. Okay, sorry. This is the data set in the Google Sheet. We go over here, publish first, and with the comma separated value. Okay, published. Okay, then get this one. This is the website. Get this one. See, that's why I was not that one. It has to be published to web first, and then go over here, and then copy and paste here. That one. Then run. Yeah, there you go. No, yes, here. See, from here, this one. See, it comes now. See. 32 observation, 4 variables here. The data set, the earlier that we just opened that one in Google spreadsheet only. It's not the way that it should be done. You don't go and then get the link of the Google Chrome, the Google spreadsheet. You have to publish and then get the link. First you're going to open and publish and then get the link, and then come back here and then recall to that, get back to the data camp. See, you're going to import those data into data camp. See, now you can do that. See, on this data set that look at on that Deloach data set, that's the same thing. Okay, this is a paper that where that is published. Get rid of this one. Then if you go to the age, okay, for the age, if you draw the histogram for age, see, you can say that you can call that one, see, GF, let's go, histogram, see, the age, comma, data would be nothing but the name of the data frame, see, copy and control V, see, see, it's the histogram, see, look at like that, see. That's how you're going to get the data into that one. But on the other hand, that if you on R, how could you going to get the spreadsheet into that R Studio? Let's talk about that one too. How do you get the data into R Studio? See? Okay, I'm gonna get rid of this one. I'm gonna open something else. Okay. I'm gonna go ahead and assignments. Okay. Answers. This one. Okay, I'm gonna open this one and show you something. you want to know. Okay, look at how they're gonna get the data set into this one. Let's say that forget about this this one, this working with the directory. Okay, how could you gonna that read data straight from that one? Let's say my data. I'm gonna give a name, my data, my day data1, my data 1. I'm gonna read from my that folder where I have saved that data. How do you read it? I can say read dot comma separated value, see, CSV data from where? I don't know where this would be. If that's the case, you can do something like this. You go to file dot choose, see, file dot choose, and you're gonna open and close. You don't know where it has been located. You are trying to find that guy, okay? And you say I need the header as well, header which is equals to give me this one. Say they are looking for the data, see, file dot choose, see, that's a one way of doing this one. We don't know where it has been located. Okay, let's run. See, when you run, it will open, see, this box, this location, this dialog box, see. On this one, you know where that now you can go and look for your data where you have installed or saved. See, you have saved data. I have saved data. See, under this one, homework, one here. See, can call from there easily. See, it came over here. See, data already here. See, you just don't write that code. You just go to the location. You're gonna just by invoking this the code, you're gonna just let the machine to that pop up a certain dialog box or that location. In that way, you can systematically go to your directory and then pick that one. See, and then now if you see, it's already there. There's no mirror mistakes. That's why that you get the see the cursor over here. See, it's been prompted over here. See, and then if you go ahead and put the head of my data 1, it will definitely print over here first 6 rows of that data, my data. See, that's a one way of picking this one. See? What's another way of doing that one? Let's talk about another way of doing this one. Okay, I'm gonna go ahead and put this one. I'm gonna say my data 2. I'm talking about the same data set, but I'm giving a different name. Okay, instead of read that CSV, I'm gonna say I read table. See, you can use that one as well. Read table. See, you choose that one header. Not only that one, you have to make sure you're gonna put something called how they've been separated. You have to mention them, how they've been separated within double inverted comma. See, you say they've been separated with this inverted comma. See, another way of that looking for the data. See, look at how I'm gonna do. Instead of CSV, I put table. Okay, I'm gonna run. Again open. Then I can easily go. You see, go through that directory and then go to that one, and pick that one, and put it over there. See, my data 2 already see in the system. If you go ahead and run this one, it will show you. See? That's another way of that getting data into the system. See, another way. See, that's another way. See, let's look at another way of getting this one. I'm gonna say my data 3 this time. Instead of the table, I'm gonna say dlim. I'm gonna use that code, that command. Then again, file choose, see, header, and you don't have to say this one because it's already been delimit. See, they are talking about that one. See, you don't have to say how they've been separated. See, and then let's talk about this one. 3. Let's see, run this one. See, again, come to that one where you are using that command to look for that one. See, open, see, and data 3 in the system. If you run that data, see, that will show you like this. See, look at, they were not, see, properly, see, they go like the, see, just like a, see, comma, because with the comma, they were not separated. See, the limbs, see, they were not separated. See, if you run that one, you can easily see that they were separated by comma. See, the first entry, okay, second entry, like that, okay, ID, household, kids, vehicles, see, price expected, income expected, business expected, financial stability, investment, income, age, employment sector, region, hours per week. So if you go to the first individual, his ID is this one, age is 33, number of kids 6, number of vehicles 2, price expected, see, 3, the income expected 5, the business expected 2, see, financial stability, the verse of, so investment, verse of income coming from stocks, age 36, employment sector number 3, the region, see, there's another one, and sorry, number 3 for that one, leisure and hospitality. The region should be west, hours per week, this one, I'm sorry, employment sector, number 3, yeah, number 3. Sorry, number, not 36, no, 30 for the, okay, let's go back. ID is this one, household, the number of people in the household, 6, okay, number of kids is 2, then number of vehicles, 3, the price expected, 5, income expected, 2, income business expected, verse of financial stability, the verse of investment, stock, income, 36, age, 30, 36,000, I think, 36 means 30, and employment sector, leisure and hospitality, the region where they were living, west, and the number of hours per week, how many hours they were working, 30, see, like that. So let's say that for this one, if you put something like, see, they were not delimited, see, it's not comma separated, see, they come like original setting. See, that's why with using that CSV, we can separate them very clearly and get like a very nice table, like a nice data frame like this. Then if you put like a, let's say that SEP like this, what would that do? Okay, let's do this one and see. Come on. Would that do anything special? Okay. You see? Now, if you put the SEP, that would tell you again to put those into like a very organized data frame. See, look at what happens if you put this one without this one, even on this one. See, if you take this out, this one, and then let's run this one. It's already here. My data too, so you can recall this one. It's already the first one, if you recall this one. So let's go to the week 1. I'm gonna go to this one, not one, April. Then go to assignment, homework 1, consumer data, open, see, okay. That one has an error because that is, since you are talking about the table, you have to make sure your separation has to be included, okay. So, come on. This one, open. See, that come nice, see. So that one, see, you can put the separation, okay, for even for this, that one. See, that's another way of that getting the data into the system, okay. What's the other way? There's another way. See, let's look at another way. Rather than that, go and look for that one, let's give the path, okay. Let's give the path. Let's give the path, okay. I'm going to give the path. Path means like a starting from where I have that save my data, okay. I'm going to go and open this one and say, okay, on this one, if I go over here, see, I have data 600, April, so assignments, under assignment, homework one, see, this is the path. I'm going to go ahead and then go to the properties. This is the directory, see, this is the path, all the way up to over there, copy. I'm going to copy that one and then put over here within inverted, I'm sorry, I'm going to use the CSV, okay, CSV, and then put everything. This one, see, this one, see, and look at consumer data, see, consumer data dot CSV. Okay, I'm gonna get out of this one and say give me the header equals T. See, let's see what's gonna happen. See, you know there's issue. This issue, see, this attached. See, take out, separate. They were attached, so he cannot read. Okay, now let's run. See, see, consumer data, CSV. There's no such file. See, at this place. Okay, let's put this one and see what's gonna happen. Double it and see. Okay, now I'm gonna go double. See, double and see consumer data. Is that the name of that one? Consumer data. I wanna see. Consumer data. Consumer data.csv. Okay, this one. See, no such file or directory. Okay, then we try it that way. Now let's get the forward slash and see. See, forward slash. Choose a forward slash. Go to assignment. Go to homework. Week 1. Consumer data. Read CSV. Cannot open file. Homework. Week 1. Consumer data. This cannot be. This cannot be. Assignment. Let's see what's going on over here. Why consume? Yeah, see, because they were separated. When you put the forward slash, you cannot put the separate. Okay. Okay. So So that's another way of doing that one. If you don't get the data, then make sure that sometime it doesn't work with the way that they have the backslash. Backslash you can change into the forward slash, and then sometimes separation doesn't work with the forward slash. It's gonna work with the backslash. Then do some kind of adjustment. Okay. So now it works. See, that's another way of reading data. See. Okay. Then you can do the same thing with the aid of that table. Okay, I'm gonna do this one again. The same setup, but you instead of here you use the table. Okay, now table, table CSV. Then this I'm gonna call this one 5. It's a fifth method. The name of the data set, and then you can remember that when you use the table, you have to put something very clearly. Separation, how they've been separated has to be mentioned. Okay, so you're going to put comma here. See, that has been done by this one. So let's run. See, good. Let's run. See, it's good. And the same way that you can get it with the dealing. Okay, let's try the dealing. But you're going to read that one straight from that place. Say that's a 6. 6. Read dealing. Like this one, you have to make sure that yeah, so 6. It's good. It's good. See, that's the way of that you can get that one from that place. Okay. Sometimes that if they were like the separated by the tabs rather than comma, you have to say the T. Okay. Here T. See, like this T. They were separated by tab. Here by comma, because of the comma, you can say comma separation, comma separated values put into a nice structure. That's what this means. Dealing or table or CSV means comma separated values. See, look at it. There are several ways you can get this done. So on the other hand, rather than doing like that way, what I'm gonna do, I'm gonna get my folder where I have saved that one. See that folder. See, when we get the folder, we were talking about this on the other time, the last time. And then when we go to the folder, and then I'm gonna call that folder my data location. And then I'm gonna change my working directory. Directory means the folder as my that folder, because I feel my everything gonna be in that folder. Let's get the folder and then give a name. That's another way of doing that one. See, that's another way of doing that one. See, so that one I'm gonna say I'm gonna go ahead and then get the data from here. See, the same thing that I up to here. See, up to here. This is my folder. The last folder. See, is the directory up to here. It's the data set. I don't go to straight to data set. I'm going to call my that folder, the last folder where that I have saved my data would be utilized as my data location. In that way, I don't have to that talk about that anything that I want to go ahead and get it from here, that I can easily get it rather than giving the whole directory, whole path again and again. I'm going to convert that to as my like a working directory. That's why I'm going to set that path as my working directory. This one as my working directory. Week 1 is my working directory. You cannot go to week 1. You have to go through this path. I go to that flash drive, go to this folder, this folder, this folder, this folder, and this is the last folder where my data, consumer data consumer underscore data being saved. So that folder I'm going to call my data location. Okay, this is how we're going to do it. We change that one. By any chance that last time we had an issue that if you're going to copy from that where that you have the folder that you had the backslashes didn't work because they were attached to this one, then we separated, it didn't work either. Later on, then if they don't work, then you put the forward slash. When the forward slash separation don't work, see, can you remember? I did over here. Follow very carefully, do some kind of adjustment. And now I'm going to say change that one. I'm going to set that to my working directory. Okay, before that I can get the directory which I'm working on right now. See, look at the working list. That's the same directory. So there's the same way. Get means get working directory. Set means like that one set as my directory. It's set now. Now go to that place and then say that. See, there's another way of reading data. See, go to that place and then you can read CSV, but you cannot do. You don't have to say anything like this. See, file not choose. This time file only. File equals name of the file and header. See, that's enough. See, then we'll get you their data. See, now you have my data. See, you have my data 1, my data 2, my data 3, 4, 5, 6, and I'm going to simply call that one my data now. You can put the head, you get that, you can put the tail, you can put, see. So the pretty much the same way. Let's see that what we can do on that Anaconda, that Navigator, that Jupyter notebook. On Jupyter notebook, how this gonna work? Let's see that what would happen. How could we gonna? Sorry, I'm gonna go to Anaconda. Launch. Let's launch this one. Notebook. See, this is the Navigator. This one has all the IDs, the platforms where you can work on, the editors. This editor for Julia, Python, and R. Let's say that if you go to R, get the R from me, and see how this gonna work. Okay. Let's say that if you put this one, would that work here? See, run. Yes, they're looking for that place. See, go to I, go to Anna, go to April, go to assignment, go to homework, go to week 1, click on. See. Now I'm gonna see here and then run that one and put the head of that one. See, it's nicely structured. See, you can see everything very nicely. See, then on RStudio. See, very nice. See, beautiful. Can I use the second setting? This one, and let's see if I can by doing this one. See, let's run this one first. See, same thing. See, open. See, to run, you get that. Let's go to third setting. See, let's go and run this one. See, again, go to that folder and then I selected my data and then record it. That's good. Then go to the fourth setting. See, let's see how it's gonna work. See, let's run this one. Now I'm gonna go straight and go to that folder and read it. See, still works. And it's the same way with the table. Going giving the whole path and read rather than go and choose. See, you get it. And go to this one, and then run. See, works. And on the other hand, can I do that directory, change the directory and work over there the same way that I'm working on RStudio. See? Run. See, my data location. Then can I set my data location as my working directory? Yes. Okay. Then can I read data from that location? Don't need this. These are the commands. comments are, I'm sorry, the comments that you're going to write on sign or hashtag. See, same thing. See, all methods even that can be sent. By any chance, if you get stuck or work in that, here very nicely they were spread out, and then you can see the results very nicely. See, than on that RStudio too. See, that's why it's a better off to have so many editors to work with. That's what we did in the very beginning. We just did the groundwork. We prepared yourself in order for you to that move forward easily. See, so that's the RStudio. See, even on the, you know how to get the data into data camp. You know how to get the data into RStudio, or R the same thing. Okay, if you want, I can show you R the same thing. We don't have to worry about R, and even Jupyter Notebook. See, like that. Okay, so that's that, and let's get back to where we were earlier. This one, this is the one. Yeah, we were okay. Oh, we are on this one. Sorry, this is easy. See? Yeah, see, that's everything we talk about how to get the data. Okay, so manipulating data. See, identifying. There are several things that you have to do when you're gonna see the data frame. Once data in a tidy format. Okay, tidy format means data variables gonna be in the column, data gonna be in, sorry, the observations or subjects or the individuals gonna be on the rows, and the same type of individuals gonna be in this one data set. If you have another data set, it's gonna be expressed separately. But any data set, R command to manipulate data. Here are a few things you might want to know how to do before you start analyzing data. You identify missing data, filtering data, creating summary variables, recording variables, creating categorical variable by cutting quantitative variables. See, categorical variables by cutting quantitative variables. See, aggregating data. Those things are that you have to do when you have a data set. Okay, so let's say that first one, so that how to identify missing data. Sometime, in fact, usually we can end up with some missing data in our data set. R represent missing data with the value NA, not available. I mentioned about that. And then also let's ask you to decide how to handle missing data in subsequent analysis. If your data set present missing data in some other way, some people put the value, see, 999. You should record the value as NA when working in R. Okay. See, if they have 999, you put the NA. Let's consider the last digits of students' social security number, SS last in the fingers data frame. First, arrange the fingers data frame so that the rows are in descending order by S, blah, 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 blah. Then print out just the variable, see, descending order, see. They want that one from the descending order. How to make the descending order this one? Can you remember? How do you get this one in descending order? See? Consider the last digit of social security number. You go this one. How do you get? Sort. Can you use a sort or arrange? You're going to arrange. See? You're going to arrange. Who are you going to arrange? You're going to arrange the SS last on these fingers. See? SS last. You go to the fingers. Fingers. You're going to go to that particular variable SS last, comma. You want to arrange that one. Descending order, no? Can you remember? Then you have to say VSC. Sorry. Fingers. Go to fingers, and then you can put the descending VASC. SS last. Arrange. And put it back into that arrange this one again. Okay, put back into fingers again. Arrange fingers. This is last. This one. Okay, then I'm gonna run that fingers. Okay, I'm gonna run not fingers, just that SS last. SS last. So this last we have to go to run that one. Okay. 93, 97, 93, 97, 88, 97, 94. See, this is the see. Some people put the law. See, we are not talking about the value of that one. Some people, the way that they have represented when they were asked about the last digits of social security number, SS last, they have given the 4 digits. Some people give 3 digits. Some people give 2 digits. Some people have given nothing. Most people did the right thing by giving their last digit. But some people still make the mistakes. See? That would not make any sense. And they are, on the other hand, not available. See, not available date. See, like that. See, you get the data, you arrange, not the sort. Sort is for the vectors. Arrange. Arrange is for that data frame for that particular variable. You go to the data set, comma, and then descending, you put like this, okay? So you arrange like that, and then you take that whatever the variables you are interested in being printed like that. Which of the following statement are true about SS last? Some student apparently did not follow the instructions to enter just the last digit of the social security number. Enter in the last 4 digits instead. See, that's true. There are missing data label within it. That's what the right thing. See. Which of the following comparison statement would true if the student had entered in some number for SS last? See, SS last. Which of the following comparison statements? See, R blanks are automatically given the label NA for not available. You can choose to remove observation with the missing data from an individual analysis, or you can remove from the data set entirely. For example, if you want to create a new data frame without missing data, you could use the comparison operator. These are the comparison operator. Greater than, less than, equal sign, not equal. See, look at the not equals. Look at how they're going to keep their equal sign. How R understand the equal sign by 2 equal signs, and not equal, exclamation mark, equal sign, to check whether the data is missing or not. See, then you're going to say, I don't need the NA1. See, do not. See, I don't need. See, SS last not equals to NA. See, NA to be taken out. That's what they were doing. They used a function called filter, command filter for the data set is the variable NA takeout. And if you want, you can put it back into the different data set with the unfiltered, with the filtered data. You can, if you want, you can put the data, filtered data back into filtered social security SS last data back into the fingers, or just put it into different one. Here they are put it into different one called the fingers.subset. So how do you do that one? See, you're going to get this one, you're going to filter. You're going to filter. How do you filter? You say that go to the data set, go to the variable, and say NA. If you see the NA, don't take them. And then you can print out the variable SS last from this one. Okay. So later on from this, okay, I'm going to run this one. It's done. Then later on, go to this data set, this data. And from that one, I'm going to look for my SS last and recall and print. See, now no more. You have NAs. NAs are gone. All NAs are gone. See, taken out. You filtered already. You can just particularly go to the variable only. See, see. The next one, how do you make the creative? That's how you're gonna see missing data. Filter. You identify the missing data. You filtered data. Okay. Now you're creating summary variable. Summary. See, how do you get the summary variable? See what that means. Summary variable. See, often we use the multiple measures of single attribute because no single measure would be adequate. For instance, it would be difficult to measure school achievement with a measure of just one course. However, if you do have multiple measures, you probably will want to aggregate them into a single variable. In the case of school achievement, a good summary measure might be the average grade earned across all student courses. See? Those are called the summary. See? Even over here, see, rather than you talking about that length of this fingers, you can talk about the average, thumb, index, and middle ring pinky. See, you can take the averages. See, like that. See, see how could you gonna get the some summary statistics? See, how could you gonna get the summary statistics? That's what we are trying to do over here. See, summary statistics. See, however, if you do multiple measures, see, it is quite common to create a new variable that summarizes values from other variables. For example, in fingers, we have a measurement for the length of each person's fingers. Thumb, index, middle, ring, pinky. By now, you should imagine this in the data frame where each person is a row and the length of each finger is in a column. You know that. Although for some purposes you may want to examine these fingers' length separately, you also might want to create a new variable based on these finger length. For example, in most people in the index finger, the second digit is shorter than the right finger, the fourth digit. We can create a new summary variable called the ring long, see, the longest one, that tells us whether someone's ring finger is longer than their index finger. We can add this new variable to our fingers back again. You are creating a new variable. We want to see that you creating a finger in which that you know that see some purposes you may want to examine these finger lengths separately. That's a different thing. But sometimes you want to create a new variable based on these finger lengths. In most people, in the index finger, the second digit, see, index finger, is shorter than the ring finger. See, shorter than the ring finger. If you go ahead and look at that, in most cases, your index finger is shorter than the ring finger. We're going to create a new summary called the ring longer. See, by doing what? See, I'm going to call that that new variable name ring longer, and will be put it back into the my fingers data frame by doing what? By you're going to compare, ask them whether ring finger is greater than index finger or not. You go to each and every individual and then check and compare and contrast. This is a comparison. You will be given not a true or false only. You don't give any value. They're going to ask, go to that the data set and go to the ring finger and then check greater than index finger. That by looking at that measurements, they're going to check ring fingers, the measurement is greater than that of the index finger. If it is true, you're going to say yes, true. See, you say true and then put it back into this one. Okay, that's why that's called the Boolean. See, they got the logical values, true or false. Okay, now let's write up the code to tally up the ring. See, ring long in fingers. See, you go over there. Okay, get this one. Okay, first run this one. Okay, and put it back into this one. Okay, and run this one. Okay, and it's been run. So now if you go to that ring longer, that one, if you want the tally of ring longer, okay, you go to the tally of this guy. Ring longer tally means up. You're gonna ask how many people, say for how many people you have a true, how many people you have a false. See, one. See, you get that one. That's for the ring long. See, that you don't get the, you get the X for reason. You know that same thing can be written this way too. Okay, that's how you're gonna get the exactly like the way they're printed below. Okay, so you're gonna go to that one. You're gonna put the tilde. Can you remember? You put the tilde, and you're gonna go ahead and say that for this guy, and then you're gonna say coming from this data, which is fingers. Let's data. See, ring longer, true or false. See, same way you had over. See. What does true mean in this context? The person's ring finger is longer than the index finger. True means how many people had that one? 89 people. 68 people didn't have that. See? You can also arithmetic operators to summarize the variable. For example, it turns out that the ratio of index to ring finger that is index divided by ring, is often used it as a health research as a crude measure of the prenatal testosterone exposure. Use this division operator to create this summary variable. Now you're going to say the name of that one is that. How do you do that one? See, you're going to go to, I'm going to get these two. Okay. Now instead of comparison, you're going to say ratio. See, you get the ratio. You're going to divide what by what? You're going to divide index to ring. See, index divided by ring. Okay, so I'm going to put index here divided by, go to fingers and get the ring. Index shorter. Your name is called the index ring ratio, and put it back into the fingers. See? Placement has 0 rows. Fingers. Index, I'm sorry. Now if you go ahead and then get this guy run, and here, that variable, if you run, see, these are the numbers for all the entries under 50, 60, 57 entries. See, those are the numbers for that particular variable. See, how would this variable be represented in tidy data frame? Index ring data would be represented as a new column in the same data frame. If you want, you can go ahead and check that one to head. And if I'm going to check fingers again, you can see the new frame. See, new column for that one. See, you can see that. Whenever you have a new variable or even do anything else in R, it's a good idea to check to make sure that R did what you intend to do. Okay, you can use the head and then go ahead and check. Okay, and also first 6 rows of the fingers. Use select to look at ring index and ring long. Ring index and those are, we can check only those variables. If you want some particular variable, you can do that one to select. Okay. Ring, you need the ring, you need the index, you need the ring long, and data, nothing but fingers. Index, ring long, data, fingers. Ring not found. What that mean? Okay. Go to fingers first. Fingers. You have to give the data first, otherwise it doesn't recognize. Okay. When you put the select, make sure you give the data set first, otherwise it doesn't recognize. Go to the data set, then variables. We're really interested now. See? You have a ring finger, you have an index finger. You're gonna see whether the index finger ring finger is greater than, longer than index finger. Okay? It might be helpful to get an average of finger length by adding up all the values of thumb, index, middle finger, and divided by 5. Write a code for adding the variable add finger to fingers that how could you gonna get that one? See, add. See, helpful to get an average finger by this one. You write the code to get adding the variables add fingers and put it this one. See, to fingers that does this one, right? Code to look at the first few lines of the fingers data frame as you see. How could you gonna create that one? Some. No. Adding who's and who's, who and who and who. See, we can say that we're gonna add these ones Let's see. Okay, what do you get? Let's see. Okay, and you have a data and cross fingers. Let's see what's gonna happen. Sum not found. That means it's not right. Okay, let's put this way. See what's gonna happen. See, so characters. Okay, now what? How do you get this added together? You have to go to this variable, this variable, this variable, see, and adding up all the values of this one. Okay. Okay, let's here. See. Yes. See, can you see? Can you see the key? Okay, let's go to this one. Okay. 1 second, they will be added. You can add this one. If we get functions. See. So if we can create a new data frame, a different summary vessel, see, function is mean. Can we get the mean? Aggregate function will give the mean. This one. Average finger length by see. Okay, I'm gonna show you that one. Okay, we have to use. We're gonna do this one. Okay. You can create this one. You can put apply. Okay. Apply. Go to my data. Okay. Go to my data. And yeah, we can give this one. Okay, I'm gonna do something like this. Okay. Summary. This one we can do like that. I'm gonna go ahead and call this one variables that I'm really interested in. Okay. What are the variables I'm interested in? These are the variables I'm interested in. Okay. I'm gonna interested in these variables. Okay. These variables. I'm gonna put them into vector. Okay. See. Then I have, okay. Then I have index. Then I have middle one. Then I have a ring finger. See? Then I have pinky. Okay. I put them into vector. I'm gonna call that one was. Okay. Later on, what I'm gonna do, I'm gonna take this out for time being, and then I'm gonna run this one. Okay. Now I go ahead and I'm gonna go ahead and was. So this one, data equals. I'll go here and go to head of my data. My data. Was. Close it. My data. Oh, I'm sorry. These are not called my data. We go to the fingers. Fingers data. Fingers. Okay. Fingers. So what I did was, look at, I narrowed down. I'm just focus only on the variables that I really need. I need the thumb, I need the index, I need the middle one, I need the ring, I need the pinky. This is what I did. See, these are called the column wise. See, this is like that matrix. Okay, this is like in matrix form. This is a data frame in a matrix form. In the matrices that we're gonna have the rows and columns. So I'm talking about the first 6 entry only. See, I forgot about the rest of all the variables. I'm focusing on this one. See, so I have a thumb, index, middle, ring, pinky. So I call them the was. Then I'm gonna recall was within columns. See, within columns while they are filling these rows. See, that's why I put empty this one, comma was. See, look at, go to fingers and give me only, narrow down my variables which are called was, which includes the thumb, index, middle, ring, a pinky, only put into like a column. See, look at how I did that. Okay, now I'm gonna apply. Okay, now I'm gonna apply. Okay, I go to that data set. I'm sorry, not mine. Fingers. Okay, that was. I go to that. I'm gonna say margin. Margin means like you're gonna do row wise or column wise. Here you have to add the numbers this way, not the column wise. I'm not talking about the average or the aggregate of the middle fingers lengths or average of the index fingers length, average of the thumb lengths. Okay, I'm looking for average of all these one. That means I have to do this way. That's why margin means, for the margin, see, margin, if you put 1, they do row wise. If you do 2, they do column wise. Okay, then function, your function is sum. Or if you want, you can put the average. See, that would give the sum. So that would give the sum for all the 157 people. That's the sum. This is the sum of the, say, 66, 79, 84, 74. If you add all this way, 66 plus, 79 plus, 84 plus, 74 plus, 57. See, if you add all these, would that add to 360? Let's see. 66 plus 79. First individual, all the sum of all that finger lengths, 84 plus 74 plus 57. Yes, that would be 360. So I did my summation this way, okay? Not the column wise. I did row wise. Look at if I put here 2. Let's see what you're gonna have. See? Then you're gonna have this entry. They're gonna say, hey, see? They're gonna say the thumb, the sum of the thumbs, all the thumb lengths would be 9,436. See? Those two can be easily tackled by this setting. Now, let's go to 1. Okay, that's what I'm looking for. 1 here. Okay. 1. Okay, I run. I got this one. These are the finger lengths of each and every person. Instead of sum, if you are interested on now you are interested on what? Now you're gonna interested in the average. Okay, let's say those are the summary measures. Instead of talking about individually, you're gonna talk about that overall all the fingers. I'm gonna put here what? The function would be mean. That's the average finger length, 72. 7. That means that you're gonna sum them up everything. 360 divided by 5. 360 divided by 5 would give you 72. 360 divided by 5, you know that. 72. You can get the average by giving this command. See? Make sure that you understand. If you want the standard deviation of that one, standard deviation, how they were, the standard deviation of all these fingers. Okay. Then you can put the standard deviation of all the fingers of all these individuals, 157. And if you want variance, let's see. I hope WoW will do that. See, that's the variance. Like that. See, those are the measuring statistics. See? Those are the measuring statistics. See, remember, okay? So, see, I use this one. See, I got whatever the variable that I want, and then I combine and put it into a vector. That vector, I put it inside the matrix. See, inside this matrix. See, inside this matrix. See, and then recall that one to be settled like this way. Okay. And then I apply my function, sum, mean, standard deviation, or whatever you want. Okay. Next one, the manipulating data. Can you remember earlier we were talking about before we're going to analyze the data, we have to do several things. 2 point structure data. See. We're going to structure data. That's okay. Then manipulating data. The manipulator, you identify the missing data, you filter data, you create the summary. Now recording value, see, okay, those things. So you are manipulating data, there is a continuation. Now, okay, let me see that. Did we finish this one? Filtering data we did. Okay, then we find the aggregate, sum, everything we did. Okay, we found already. Okay. Recording, see, recording, not recording, recording. There are some instances where we want to add a label onto numbers. You don't like the numbers, you want to add the number. There are other cases when you want to change the numbers themselves. Either you want to change the numbers or add a new the label to the numbers. Okay. For instance, the variable job is coded one for no job, 2 for part-time job, 3 for full-time job. Perhaps you want to recode full-time job as 100 instead of 3, and maybe you will also record part-time job as 50 instead of 2. We will record no job as 0 instead of 1. See, this is how you're going to record. See, you go to the fingers, you go to the job, comma, 1 being replaced by 0, 2 being replaced by 50, 3 being replaced by this. See, now no longer you're going to see 1, 2, 3. See, these are the old label, these are new label. See, you're going to see this one like this. See? See? So it's the same way. See, save the record version of the job to the job record. See, you can get this one and then save to, see, save to new variable called job record in fingers data, and write and compute the job and see, and write code to print a few observations. See, now you can get the, see, you can go to the fingers and then you can go to what job you can say print and head of what and what. Fingers, go to fingers. You don't have to say sorry. Head, go to fingers. You go to fingers and then let's do this one. Job, comma, job is called record. Job dot record. That means it doesn't work. This one, fingers. You have to go to this one. And then get this one. And fingers. Whatever. This one. 2. See. Job dot record. See, now instead of that one you have a 0, 0. See, 1 being replaced by 0, whatever you call 1, 2, 3, now 0, 50 and 100. See? See, job and record. You can job record this one. Remember that we got this one, got that. Okay, yes, you can go to select. You can go to select. Okay, select and go to head. I'm gonna go to head and then separate select. Go to fingers and go to job. Go to job and then go to job records. Close it. Okay. Select fingers, go to data, key to the variable, go to the other variable. See, like that. You're going to get the job, non-job record. You select, okay. Select and get the first 6, okay. Then next one is very interesting. You create in the categorical variable by cutting quantitative variable. This is very interesting. Okay, let's see. Sometimes it might be helpful to look at the quantitative variable in a categorical way. Quantitative you can convert into a categorical way. For example, if you want to split up the student in the fingers data set into 2 groups by the height, by their height, rather than go by the heights. You don't want heights, numbers. You want to just divide them into that categorically 2 groups, a short group and tall group. You could use the function called entile. Entile means quantile. Entile means quantile, okay? Quantile, I'll talk about that one, okay, in detail. Quantile. See? Called the quantile. Quantile. I'm sorry, this one. What are called the quantiles. So, I want to make sure that just mention about the quantile a little bit for your convenience. Looking for something to quantile. Quantile. Let's see where this. Looking for that one. Okay, looking for some notes to have a look at it. That's okay. Okay. So, see, those are called the quantiles. See? Quantiles. Quantiles means like if you have a this variable data you can divide into 2. See, whole data set. You have a let's say that you have a data means like a variable, okay, variable. You have a variable, you have a minimum value, min, you have a max value. You want to divide this into 2 parts. You don't want to go by the numbers. You want to say that there are 2 groups. This will be divided into 2 parts by the something called the median. See, then you have 1 and see 2 tiles. See, sometimes you want to divide this into 3 parts. In order to do 3 parts, you need the here. In order to divide this into 2 parts, you need only 1 divisor. See, 1 divisor. See, 1 divisor makes it 2 parts. Let's say you have a data being rearranged from minimum to see in ascending order. See, data. See, arranged in ascending or descending order. Doesn't matter. Order going from the minimum to maximum. Now you want to divide this into 3 parts. Then you need see. This is like a quantile 1. This is a quantile 2. See. If you do this one, these devices are called the terciles. Terciles. That means you divide this one into 3 parts. 1, 2, 3 with the aid of 2. Terciles. Since with terciles. This one's first one is median. That if you have a data set, you have a minimum here, maximum value here. You're going to divide this into 4 parts. In order to do 4 parts, equal 4 parts, okay, you need, see, Q1, Q2, Q3. I'm going to say this one tercile T1, okay, to make it sure, T1, T2. See? Tercile 1, tercile 2. Here, those are called, if you want to divide this into 4 parts, these are called quartiles. See? Quartiles. Quartile. But you need only 3 quartiles. Quartile 1, quartile 2, quartile 3 together, 4 groups. And you can keep going. Okay? Keep going. That's why rather than having the numerical values, you can divide that into groups using quantile. Quantile is the same word, same that the function we use over here, entile. See? Using the entile. See? Look at that. You're going to go to the height and say, hey, give me the, divide this into 2 parts. 2 parts. See? 2 parts. Your entile would be 2. The same way that we did over here. See? You don't need that the numbers for the height. You don't need the numbers for the height. You just simply say, hey, give me like 2 parts, and then you give them a label. They're going to automatically, by default, they're going to give the label as well. See, 1 and 2, 1 and 2, 1 and 2, 1 and 2. Those are the default label. See, by default, you have the thing. See, sometimes variable in a way, for example, blah, blah, blah. Entire comes from the idea that if you sort a quantitative variable, you could then divide the observation into groups of equal size. So you could have the tertiles. See, I told you, tertiles, 3 groups, quartiles, 4 groups, quantile, 5 groups, decile, see, keep going, percentile, if it is 100, see, terciles or tertiles, okay, sometimes they call the tertiles or terciles when you have a 3 groups, terciles or tertiles, tiles, okay. See, if you have like a 5 groups, see, quartile, quintuple, see, 5 groups, quantile, see, these are quartile, the other one quantile, see, 5 groups, see, quantile. How many tiles you need? 1 tile or 2 tiles or see, 1 tile, see, 2 tile, see, tiles. How many tiles you need? How many layers you need? See, if you have 3 groups, if you have 2 groups, you have a median. Okay, that's the starting point. It's going to start from 3, as you're seeing over here, 3 groups. Tercile, quartiles. If it is 5, quantile, 6 hexiles, 7 heptiles, 8 octiles, 9 noniles, 10 deciles, 10 groups. This is the most important one, quartiles. We have most of the time use the quartiles. Can you remember any data set if you want to find the quartiles, Q1, Q2, Q3? See, if it is being divided into 5 parts with the aid of, see, with the aid of this devices, those devices are called the quantiles. Okay, these are the quantiles. See? Now, entile comes from the idea that, see, entile comes from that idea. Entile, see, from the idea quantitative is maybe like a quartile like that. Running this code, look at if you run this one, they're going to give that label. See, running the code will divide the student into 2 equal groups, those taller than the middle student and those shorter. How could you going to do that one? How they going to divide? How going to he decide that where the cutoff point? Any student who been arranged like that way, this way, okay, then if they're going to divide into 2 parts, they're going to go ahead and calculate the median. He calculates the median, and everybody whose height is less than or equal to median called 1, greater than median called the 2. That's how he does that. The program or the machine will do that one for us. He's going to calculate this guy. How do you calculate the median? Median very easy. Given a data set, you're going to go to what? You're going to just separate the data set. If you have like a small data set, let's say that 3, 4, 5, 6, 7, 8. Okay, they've been that arranged in that ascending order. If you want that, I'm going to count 1, 2, 3, 4, 5, 6, and I have a 3 here. I'm going to put another one here, another 6. Okay, 3, 3. This is the seventh one. It's the median. That's the middle one. The middle location called the median. See, that's the median. See, that's the median. See, how do you calculate that one? They can easily calculate what they're going to do. They're going to go to the sample size, which is n, okay? And they're going to go ahead and find the location of median. How do you find the location of median? See, n divided by 2. See, n divided by 2. See, n divided by 2, then 7 divided by 2, 3.5. Since this is a decimal, you're going to round up to 4. You go to the fourth location. This is the location. Okay, you go to the fourth location. 1, 2, 6. This is the first location. This is the second location, third location, fourth location. That's the way how you're going to find it. Let's say that you have so you're going to divide this into 3 parts. Okay, let's say that tertiles. See, 3 parts. How do you figure out this T1 and T2? Is the minimum, is the maximum. The number of data will be n. How do you find out that one? You're going to go to the location of T1. How do you find the location of T1? N divided by 3 instead of 2 now. See? N divided by 2. How to go to the location of T2? N divided by 3 times 2. See? Second location, see? Like that. See? In the same data set, if you have like a 7 divided by 3, see? 7 divided by 3, they say that this is 3, okay? 3, we don't know, okay? 4, 5, 6, 7, 8. I'm going to say 8 here equals this one, okay? Like that data set, see? Okay, 8 here, maximum. 7 divided by 3, what do you get? 2 point something, okay? That means you're going to go to third location, see? Look at this one, see? 2.3.